Welcome to another American Beauty product support video tutorial.
We're looking at the model 10504 soldering system. It's an A12 250 watt power unit, a model 105 127 handpiece. The basic electrodes that come in this handpiece are straight 3-inch rods. We recommend that you modify those, put about a 30-degree bend in those for aerodynamic purposes, a little friendlier handling. Okay, what we're going to be doing is we're going to be soldering some terminals. They've been crimped on, and we've got multiple sizes. We're going to start with this 10 gauge size and try and keep things centered in the picture. We've got a run light here. This is not something that comes with the system. It's only there for your edification so you can see the actual dwell time during the soldering process. I'll try and stay in a close proximity so you can see that taking place. Okay, and this is the solder that was actually provided by the end user, so we're going to stick with what they've provided. You can see the color change on the terminal. They want a nice full feed on there. Okay. Now I'm going to dial this up just a little bit. I'm not at maximum right now. I'm about 80%. I'm going to dial this up just to speed the process up a little bit. I'm just trying to stay centered on the neck of the terminal so that I have a better balanced amount of thermal energy. There you see that's a little bit quicker. Okay, and we've got one more of the 10 gauge. Now you can also have these in a fixture or clamping device holding multiple wires ready to do, and then you can just move your tweezer from one to the next for your soldering process. I'll move these out of the picture here. We're going to step this down now. These are a 12 gauge wire. Same basic principle. And I'll go ahead and leave the power where it's at for right now. As we get into the smaller sizes, we might want to dial that back down. Okay, you need to keep the electrodes clean so they don't foul like you just saw. You can actually feel when they're working. There's a slight vibration. You clean them with an emery cloth, a jeweler's file, something that lightly abrades the electrodes to give you a greater longevity.
Question we get a lot is, where does that vibration come from?
Okay, the vibration is actually the current itself is a 60 cycle or 60 hertz common American electrical source. European is like 50 and America is 60. That's a 60 cycle hum is what we call that.
This refers to the input 120 volt AC current being delivered at 60 cycles per second.
And that's what that hum is. And you wouldn't really notice it like in a 60 watt light bulb, but when you get into applications like this where we've actually amplified the amperage and lowered the voltage, it's a little more aggressive power. Okay, we're stepping down now to a 14 gauge wire. Everything is tied to the physical mass that you're trying to heat. And everything about resistance is power and time. If your dwell time is taking too long, then you can just turn your power up. You want to increase it to be at a level that's most efficient for the application. And you can actually have it up too high. What that involves is actual you're too overzealous, you'll actually ramp it up so hot that the solder will just boil off of the components and not even stick to it. At that point, you know you're too high, and so you need to dial it down. Okay, we're going to step this down again, and these are a 16 gauge wire terminal. And I am going to turn the power down just a little bit. And everything you do with this type of application is trial and error. But once you've established a working process, it's going to be very repeatable, very consistent. So the basic idea is to be able to get in, get a good throughput, good quality, good repeatable quality, and then that's the process you would outline for your operators. And like I said, you can have these like stationed in a vise or something where they're sitting side by side, and you can then just move from one wire to the next, boom, 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 to get a more fluid process and application.
Once you have eliminated material and operator variables from your process, the next consideration might be dwell time.
We have a standalone timer device that can be used with our equipment. And it actually was specially designed to be used with this equipment because of the, let's call it, magnetic flux that's produced from the transformer. And through some of our own internal trial and error and development, we found the right timer unit that would work, and we've incorporated it into a box. And the timer itself, the timer unit, is a multi-function device, and it's got about 13 different formats that you can imply. It's got like a momentary, it's got like a quick button, you know, you hit it once and it cycles out for the full time. It's got a setting where you can set it for a time, and it only runs for the duration while you're holding the foot switch. So there's ways to incorporate that for what I guess you're getting at is repeatability.
That's the word I was looking for.
Yeah, so to incorporate a better repeatability, this multifunction timer unit actually goes down to hundredths of a second. And so like I say, trial and error, get your process established, and then refine it, and then gain that extra repeatability by using a timer unit. Okay, so I've taken that all the way from a 10 gauge down to a 20 gauge termination, and that's our show for today.